System of equations, part D. Matrix method. In the previous sessions, we have solved using various methods, but in this session, we will solve using the matrix method. Okay. We will use two main things in the matrix multiplication and the matrix inversion. Okay. So we'll have quick revision in the coefficients. So find the coefficient of x is the number multiplied to x, so it will be 2. Find the coefficient of y, so it's the number that's multiplied to the y, so it will be 5. Then the coefficient of z, it's the number multiplied to that, and it's the negative 3. Don't forget the sign. If there is a negative, don't forget it. So the coefficient of z is negative 3. Okay. Find the order of the following matrix. This is a quick revision in the matrix orders. So let's see here the order of the first matrix. Let's count the rows. These are the rows and these are the columns. Okay, so let's count them. So we have 1 row, 2 rows. Okay, for the column we have 1, 2, 3, 4. So we write them in this format. Rows multiply columns. So we have 2 rows, so it will be 2 multiply 4. Okay, for the second matrix, let's count the rows. 1, 2, 3. Okay, for the columns, 1, 2, 3. So to write them, it's R multiply C, rows multiply columns, so it will be 3 times 3. Okay, matrices multiplication. To be able to multiply two matrices, M1 and M2, let's see here. We have M1, row 1, multiply column 1, multiply M2, which has row 2 multiply column 2. In order to be able to multiply these two matrices, column 1 of M1 and row 2 of M2 must be equal to each other. And so the result will be row 1 and column 2. Okay? As if the inner must be equal to each other, and the result of the multiplication will be the outer. So M3, which will be the result of the multiplication of M1 and M2, will be row 1 multiply column 2. Okay. But what if C1 is not equal to R2? Then M1 can be multiplied to M2. The multiplication can take place. Okay, find the result of the multiplication. We have here two matrices. We want to multiply them to each other, but before we can multiply them, we must see their rows here. Here the rows and columns. We have here 2 rows and 3 columns, and in the second matrix we have 2 rows and 2 columns. Can we multiply them? Let's see. No, the 3 is not equal to 2, so this multiplication can't take place. Okay, this is the first matrix here, and this is the second matrix. Let's see if we can multiply them. But first, let's see the rows and columns of the first matrix. The first matrix have only 2 rows and 7 columns, and the second matrix have 3 rows and 2 columns. Let's see if we can multiply them. No, the 7 is not equal to the 3, so this multiplication can't take place. Okay, exercise 3. Find the result of the multiplication. Let's see here. This matrix is 2 by 2 and this is 2 by 2. So 2 is equal to 2, then this multiplication can take place easily. And I want you to see here. The first row of this matrix, we will take the first row of this matrix. Okay, the first row of the first matrix and the first column of the second matrix. Okay, first row and first column. So where will be the result located at the first row and the first column? Here. Okay, so what will be the result that will be here in the first row and first column? It will be like a dot product of 0 and 9 and 1 and 2. Okay, so 0 will be multiplied to 1 and 9 will be multiplied to 2. Just like that. 0 times 1 plus 9 times 2. This is the result that will be in the first row and the first column. Okay, so you will take the first row and the second column. So the result will be here. The first row and the second column. Okay, and we'll do exactly the same. 0 and 9 multiply dot product to 8 and 1. So 8 will be multiplied to 0 plus 9 times 1. So as you see here, 0 multiply 8 plus 9 times 1. Okay, we are done here with the first rows. Then we'll take the second row, 2 and 1, and the first column, second row and first column here. It will be the second row, number 2, and the first column, column number 1 here. So 2 will be multiplied to 1 and the 1 will be multiplied to 2, so it will be 2 times 1 plus 1 times 2. Okay, you'll take the second column here, so it will be the second row and the second column. The result will be here. 2 multiply 8 plus 1 times 1, so it will be here. So let's calculate the results. The first will be 18 and the second here will be 9. And for the second row, the first column will be 2 and it will be 4, and here it will be 17. So this is the result of the multiplication. 18, 9, 4, 17. Okay, let's see here. This is an easier multiplication. You will take first the first row with the first column, or we can say the only column here. Okay, so 1 and 1, 0 and 5. So we'll have 1 multiply 0 plus 1 times 5, and you'll take the second row, 0 and 8 times 0 and 5, so 0 times 0 and 8 times 5, so the result will be 5 and 40. Okay, to get the inverse of the matrix, it's just like getting a reciprocal of the number, or the multiplicative inverse of the number. Let's see here. We have 8. To get the inverse of 8, it will be 1 over 8. Or you can call it 8 power negative 1. Okay, what will happen if you multiplied 8 and the inverse of 8? So we will have 8 times 1 over 8. So they will cancel each other. So the result will be equal to 1. You see here, they negate each other. Okay, let's see here. If we have a matrix A, and we get the inverse of matrix A. So it will be A power negative 1 or A inverse. But what if we multiplied the two matrices A and the inverse of A? So we have A multiply A power negative 1. The result will be I, identity matrix. The identity matrix is always like a square, okay? And it's always have a diagonal of ones, okay? It's always a square. 3 by 3, 2 by 2. It's always it will always look like that, okay? Okay. Now the steps to get the inverse of a matrix. Let's say this matrix M have components A, B, C, and D. We want to get its inverse. Okay, so we'll get the inverse here, minus 1. So the first step, we will get 1 over A multiply D minus B multiply C. A, D, and B and C. Okay, but the A and D minus B and C, they're called the determinant, or they sometimes point at it like an absolute value of M, and it can't be equal to 0. If it's equal to 0, then this matrix have no inverse. You can get the inverse of this matrix. Okay? Okay. Okay, and the second part is very easy. Actually, you replace these two. You replace A and D and negate these two, the C and B. So we will have here D will take the place of A, and A will take the place of D, and we'll have negative B and negative C. See, very easy, very easy. Okay, so let's get the inverse of this matrix, 0 and 1, 5 and 3. So you'll get the first step, you'll get 0 times 3, 1 over 0 times 3, minus 1 times 5. So 0 times 3 will be 0, minus 1 times 5, it will be minus 5, so it will be 1 over negative 5, or we can call it negative 1 over 5. Okay, now the easier step, we'll replace these two, the 0 and 3, and we'll negate these two, the 1 and the 5. So it will be 3 and negative 1 and negative 5 and 0. Okay, now to the most important part here, solving a system of equations using the matrix. Okay, let's see here. We have x, a1x, this is the coefficient of x, b1y, and c1. Okay, a2x, b2y, and c2. This is the two equations here, and I pointed to them using simples because we will see the rule here. Okay, so first we will need three matrices. Okay, three matrices. First the matrix A, then the matrix X, and the matrix B. Okay, let's go back a little. Matrix A will take the coefficients of the first equation, A1 the coefficient of X, and B1 the coefficient of Y. And in the second row, it will take the coefficients of the second equation, A2 and B2. So you'll have here A2 and B2. So this is the matrix A is just for coefficients, okay? Okay, then the matrix X is just for the variables, X and Y. So we have here two variables, X and Y. We want to know their values. So these are the component of the matrix X. And you know, if you multiply them, row 1 times column 1 and row 2 times column 2, they will give you these two equations. You can multiply them if you want and check them if you want. Okay, and next is the after the equal, the B matrix, which will contain the result of the equation or the constant after the equation here, C1 and C2. Okay, let's see here. We have AX equal B. Matrix A times matrix X equal the matrix B. Okay, so remember, if we multiply these two sides of the equation here with A inverse, A minus 1. So you'll have A minus 1, AX equal B, A minus 1. Okay, so A minus 1 and A will give you an identity matrix. Like remember here, IX, identity matrix, if it's multiplied to any matrix, the matrix will remain the same. So X multiply Y will be equal X equal B, A inverse. So as you see here, the identity matrix is just like the one in the normal multiplication. It won't affect the multiplication. Okay, so we will multiply the matrix B by the inverse of matrix A to get the value of matrix X. You see, very easy, very easy. You don't even need this proof, you know, you will just need this part. B multiply the inverse of matrix A. That's it. You see how easy it is? Okay, let's see here. Find the values of X and Y using the matrices. Okay, so we have X plus Y equal 21 and X equal 2Y minus 3. Okay, we must put this in a form like the first one. So we want to get the 2y before the equal sign. So we have x minus 2y equal negative 3. Okay, we have arranged the two equations here and they are ready. So we get the matrix A with the coefficient of the first equation 1 and 1 and the coefficient of the second equation 1 and negative 2. Okay, so for the matrix X it will be X and Y, and for the values here matrix it will be B, and it's 21 and negative 3. Okay, so the first step, you want to get A inverse. A inverse, okay? So it will be, you will take here 1 times negative 2 minus 1 times 1. Okay, this is the determinant here. So the result will be negative 1 over 3. And the next step, you will replace these two and negate these two. So we'll have here -2 and 1, -1 and -1 here. See? Very easy. Okay, so this is A inverse. This is all the A inverse, -1/3. Some people will say, let's multiply them. I'll say no. Keep it like that. Keep it like that to the end. Don't want to get fractions and make the multiplication more complex. Let's keep it simple, and we multiply this at the end. Okay, now we get the inverse of A. Remember here, when we multiply both with the inverse of A, the x will be B multiply A inverse. So you multiply A inverse to B, and that's it. We get x. So let's do that now. You have x, it will be equal B, and the A inverse. So we have the A inverse, -1/3, and -1, -1 and 1, and B, 21 and -3. So let's multiply these two matrices first. Then we will get here the first row with the first column. So it will -2 times 21 and -1 times -3. So, and a second row and the column here, -1 times 21 and 1 times -3. Okay, calculate the result. So it will be -39 over -24. Okay, don't forget the -1/3. So you'll get it here. -1/3 multiply -3, 39 over -24. So you multiply the -1/3 to both components. So -39 multiply -1/3 and -24 multiply -1/3. So the result will be 13/8. So here you go. The value of x will be 13 and the value of y will be 8. Here you have solved the system of equations using a matrix.